Hello, everyone. My name is Muhammad Aizahawan bin Razlan, and today we're going to take a deep dive into solar PV and biogas implementation in University Malaya for energy savings. This is the agenda for today: introduction, literature review, site selection, resource for biogas, solar PV energy, total energy savings, environmental benefits, applications in University Malaya, conclusion, and references. We begin with the introduction. University Malaya is Malaysia's oldest university. It has continuously prompted rising electricity demand and environmental concerns. This has encouraged the adoption of renewable energy technologies. These technologies are the solar photovoltaic (PV) systems and biogas energy generation. The goal for this implementation is to reduce the dependence on the grid of electricity and improve energy efficiency within UM. This is also to achieve lower running costs in the future if all goes well and is fully implemented. Literature review. This is to open your minds to what is solar photovoltaic technology and biogas technology. Solar PV converts sunlight directly into electricity through photovoltaic cells. The average irradiation in Kuala Lumpur is about 5.4 kilowatt hours per meter per day. The grid connected PV systems are technically feasible and environmentally beneficial for campus applications. On the other hand, for biogas technology, biogas is produced through the anaerobic digestion of organic waste. The common feedstocks include food waste, cafeteria leftovers, garden waste, and animal manure. Typical biogas composition is about 50 to 70% methane and 30 to 50% carbon dioxide. These biogas can be used for electricity generation or fuel. For the site selection, solar PV have their own suitable location. They're more suitable on top of rooftops of lecture halls, library buildings, faculty buildings, and car park solar canopies. And they also have their criteria, which is high solar exposure, minimal shading, large roof area, and easy maintenance access. For the biogas plant location, it's more suitable near residential colleges and cafeterias. And the criteria of the location needs to be a continuous supply of food waste, reduce transportation costs, and away from academic buildings to minimize odor concerns. And now we move to the resource for biogas production. Typically, we can get the resource for biogas from student cafeterias and residential colleges via kitchen and food waste. We can also get resources from landscaping activities, which are grass and leaves. And we can also get a resource for biogas from event centers, and they can give us organic leftovers. Now for the calculation based on an estimation. It's not necessarily an estimation, but it's from a report, the University Malaya Waste Management Report. And it says University Malaya produces approximately 400 tons of food waste annually. Part of this waste is already treated through anaerobic composting and anaerobic digestion programs. But if we take the estimation and apply it to the present, we would get about 400,000 kilograms of food waste per year. And if we take that continuing forward and put it through the calculation of zero point 0.0, which is the estimation of how much gas we would get per kilogram of food waste, we will get about 400, not 400, but 40,000 meter cubic of gas per year. And if we take that and times by 6, which is how much energy we can get from per cubic meter of gas, we will get about 240,000 kilowatt hours per year. And that's a lot. Calculation for solar PV energy. If University Malaya receives an average amount of 4.5 peak sun hours per day, the solar PV calculation would be as follows: 4.5 kilowatt hours times 500 kilowatt power would be an equal to 2,250 kilowatt hours per day. And if we times that by 365, we will get 821,250 kilowatt hours per year. The total energy savings. First, we need to identify the source of energy, which is biogas technology and solar PV technology. The energy produced 109,500 kilowatt hours per year from biogas technology. And we will get 821,250 kilowatt hours per year from solar PV technology, which gets us a total of 930,750 kilowatt hours per year. And if we assume that the electricity tariff would be about RM 50 cent per kilowatt hour, times that with the total from before, and we will get about 465,375 ringgit per year. You could therefore you can potentially save approximately about 465,000 ringgit per year. All in all, it's still not just a money issue. It also solves an environmental issue, which it can reduce the emission of carbon to the environment because we can create a less dependence on fossil fuels for energy, electricity generation. We can also reduce waste because food waste is diverted from landfills and is used for biogas production. And finally, it serves as a sustainable campus development by following the SDG 7, which is the affordable and clean energy, and SDG 13, which is climate action. In conclusion, implementing solar PV and biogas systems at University of Malaya offers significant long-term energy savings. Annually, it can generate approximately 930,750 kilowatt hours of electricity. And with that, it has the potential of saving about 465,375 ringgit annually. And from an environmental point of view, these technologies can reduce carbon emissions, promote better waste management, and support University Malaya's vision of becoming a sustainable and low carbon eco campus. These are the references, a lot of references, a whole lot more references. And we've reached the end. Thank you for your time and thank you for listening. And thank you for the lecturers for lecturing me regarding this course. Bye.